For decades, the flying car has been the ultimate promise of the future, but it's always stayed just out of reach. The problem has always been physics. Cars need to be heavy to be safe on the road. Planes need to be light to stay in the air. Trying to smash those two things together usually gives you a bad car and an even worse plane. But at the 2025 Shanghai International Auto Show, GAC Aeon unveiled a game-changing solution that sidestepped this dilemma entirely. The GOVE, a groundbreaking vehicle, doesn't attempt to fuse the car and aircraft into a single unit. Instead, it splits them apart, allowing each to specialize in its respective domain. The result is a system where the car and the aircraft work together seamlessly, yet are completely independent in their functions. The GOVE, originally revealed as a prototype in 2023, has since evolved into a fully realized commercial strategy under GAC's new aviation brand, GOVE. The core concept is one of decoupling, separating the vehicle's ground and air components into distinct machines that perform their tasks without the weight or structural limitations of hybrid designs. In traditional flying car prototypes, the vehicle must carry the weight of both road and air components, resulting in a significant drain on battery life and flight efficiency. The GOVE bypasses this challenge by keeping the chassis, with its weighty road components, firmly grounded. When the GOVE is on the road, its flight cabin is attached to a four-wheeled electric chassis, which drives like a sports car, drawing power from the chassis' battery pack. However, when traffic snarls or a faster route is needed, the flight cabin detaches from the chassis, unfolding 6 arms and 12 rotors, which allow it to lift vertically into the air. The heavy ground components remain behind, freeing the flight cabin to take off with ease. This modular design allows for specialized engineering that maximizes efficiency. The flight cabin itself is constructed from lightweight composite materials, making it nearly 90% lighter than a traditional car body. Without the burden of carrying road components, the cabin is able to fly with unparalleled efficiency, something hybrid flying cars simply cannot match. The propulsion system is configured as a distributed multi-rotor system, a critical safety feature that enhances stability. Unlike a helicopter, which relies on a single main rotor, the GOVE's 12 independent rotors ensure that if one motor fails or a blade is damaged, the flight computer will instantly adjust power to the remaining rotors, maintaining stability. This redundancy is essential for meeting aviation safety standards, and its importance cannot be overstated in the pursuit of certification from aviation authorities. Meanwhile, the ground chassis isn't left idle while the cabin flies. Equipped with GAC's ADI pilot system, a high-level autonomous driving platform, the chassis becomes a fully autonomous robot once the flight cabin detaches. This means the chassis can autonomously drive itself to a nearby charging station to recharge its battery, or navigate to a different landing pad to pick up another incoming flight pod. This creates a continuous, efficient loop of utility, a system where the user not only owns the flight capability, but the ground mobility can be shared or managed automatically, alleviating the need for parking in crowded urban centers. GAC's ambitions for the GOVE extend far beyond the confines of a single product. By 2025, the company clarified that the GOVE was just one part of a larger ecosystem, designed for both intracity and intercity applications. The GOVE itself is intended for short hops within a city, perfect for bypassing congested traffic or for crossing urban cores where ground transportation is sluggish and inefficient. For longer distances, GAC introduced the GOVE AirJet, a larger aircraft that relies on a different aerodynamic approach. While the GOVE uses rotors for vertical lift, the AirJet employs a composite wing and pusher propellers, allowing it to fly like a conventional airplane once it reaches altitude. This approach offers higher speeds in a range exceeding 200 kilometers. In this vision, a user might take a GOVE to a local hub, then seamlessly transfer to an AirJet for intercity travel, enabling an entirely new mode of regional transportation. GAC's ambitions are not only technologically ambitious, but also strategically targeted. The company has focused its development on the Guangdong, Hong Kong, Macau Greater Bay Area, one of the most densely populated and economically powerful regions in the world. Despite this wealth, The area is geographically fragmented, with borders and waterways creating significant challenges for traditional ground transportation. Long-distance travel between Shenzhen, Guangzhou, and Hong Kong can be slow and inefficient, often taking hours due to traffic congestion and the geographical layout. GAC aims to create a 40-minute living circle, dramatically reducing travel times and making the area more interconnected through short, direct flights. The company is on track to begin pilot operations in this region by 2027, hoping to demonstrate the practicality of this low-altitude transport network within one of the world's busiest economic zones. The flight experience in the GOVE is meticulously designed to be intuitive and accessible for a wide range of people, from tech enthusiasts to everyday commuters. Unlike traditional aircraft, which require hours of training and a solid understanding of flight dynamics, the GOVE eliminates the need for a pilot altogether. Passengers simply input their desired destination, and from there, the flight computer takes over. The vehicle autonomously manages complex aspects of the flight, such as stabilization, wind correction, and trajectory control, ensuring that the aircraft remains on course under a variety of conditions. This automated system significantly reduces the margin for error, making the GOVE not only easy to operate, but also incredibly safe. Even those with no aviation experience can board the GOVE, input their destination, and take off with confidence, knowing that the flight computer will handle the technicalities. This simplicity and ease of use are key components of GAC's vision for the GOVE, making personal flight accessible to a much wider audience than traditional aviation could ever hope to. The system's design also anticipates the future of air travel. The GOVE is built to integrate seamlessly with upcoming air traffic control networks, which will be crucial as autonomous flying vehicles become more common in urban airspace. These air traffic systems will be able to monitor and manage the movement of thousands of autonomous aircraft, ensuring safety and coordination as the skies above cities become increasingly crowded. However, the development of such revolutionary technology does not happen in a vacuum. Regulatory progress has been a crucial factor in the GOVE's evolution. China, recognizing the potential of low-altitude urban air travel, has been particularly proactive in opening up low-altitude airspace for commercial use. The government has already established a legal framework that allows companies like GAC to test and refine their vehicles within controlled environments. This proactive regulatory stance has been essential for the successful development of the GOVE, as it allows the company to push the boundaries of what's possible in aviation while adhering to safety and compliance standards. The GOVE itself has already undergone extensive flight testing to validate its structural integrity, noise performance, and overall safety. Noise pollution is one of the biggest concerns when it comes to urban flight. The last thing anyone wants is a constant drone of flying vehicles disrupting the peace of a bustling city. GAC has been particularly thoughtful in addressing this issue. The rotors of the GOVE have been engineered to operate at specific frequencies that blend seamlessly into the ambient city soundscape instead of contributing to it. Rather than creating a disruptive, deafening hum like traditional helicopters or drones, the GOVE's rotors operate at a quieter, more natural frequency, ensuring that urban environments remain relatively peaceful even with numerous flying vehicles overhead. This attention to noise design could make all the difference in the acceptance of flying vehicles in cities around the world, as noise pollution continues to be a growing concern in urban areas. The official launch of the GOVE brand marks a monumental shift in the evolution of flying vehicles. For decades, the flying car existed only in science fiction or as an impractical fantasy. It was the stuff of Jetson-style dreams, something far beyond reach. But the GOVE is not a whimsical idea. It's a functional, fully realized product that has the potential to revolutionize how we move from place to place. GAC has achieved what others have failed to do by decoupling the road and air components. In doing so, they've removed the most significant physical and engineering hurdles that have hindered previous attempts at flying cars. The result is a vehicle that doesn't require trade-offs. It's efficient both on the ground and in the air. As an electric car, it provides a smooth, efficient ride on the road. In the air, it sheds unnecessary weight, making flight both more efficient and sustainable. Looking ahead to 2027 and beyond, the GOVE stands as a testament to a new era of transportation design. It challenges the conventional limits of what we thought possible in personal mobility. No longer is the road the end of the line. Now it's just a launch pad. The GOVE has set the stage for a future where the barriers between land and air are no longer as rigid, and where vertical mobility could be just as accessible and commonplace as traditional driving. It's not just a new kind of car, it's the beginning of a transportation revolution.